All right, welcome back to Fortran Bootcamp, part 2. Today we're going to talk about variable types. So, F95. Okay, I don't like that little space there. Okay, so let's create another program. We'll call this one variables. Again, we want the implicit none statement to say that we're not dealing with any, we're not asking the compiler to figure out what our variable types are. There are five built-in variable types in Fortran. You have integers, reals, which are floating point numbers, character, logical, which is a Boolean, so true or false, and complex. That is one of the really cool things about Fortran. Complex numbers are built in.
Nice.
Yeah, it's sick. Anyway, so let's just declare some variables. We'll just declare integer. We'll call it myInt. We've got a real called myReal. We'll do a character. We'll call that myChar. Don't say char. Just don't. We'll declare logical, my logical, and then a complex, my complex. Now I want to see what all these are, so I'm going to write out, well, I guess I got to initialize them. It's really good practice to comment everything in your code. It makes it so that when you're going back, you know what you were doing, because a lot of people think, oh, I'll remember what I was doing. You won't, most of the time. So put in comments to do yourself a favor, to do other people a favor, and I find it helpful to just kind of, structure my thinking. If I am creating a program or a function, often what I'll do is I'll go in and I'll write out in comments like, do this, then do that, then do that. And so I have like the basic framework just all in comments, and then I can fill in the code in between. That's helpful for me. Anyway, let's initialize all these. We'll say myInt. We'll give that a value of 1. myReal is equal to 1. I've gotten in the habit that anytime I declare a floating point number, I just put a decimal point after it, even if it doesn't need it. Fortran doesn't care. The compiler doesn't care. This is kind of just for me to be able to keep track of things. myChar is equal to, another wonderful thing about Fortran, it doesn't care, or it makes no distinction between
Single quotations and double quotations?
yes, thank you. Single quotations and double quotations. Another important thing to remember, Fortran does not differentiate between lower and uppercase letters.
Oh, really?
Yes. Which is really fun, because if you go back and you look at like Fortran 77 code written by the hardcore old-timers, it's written as if they just had caps lock on. Like the entire code is screaming at you, and it's horrible, but whatever.
So it used to be case sensitive, and now it isn't. Is that what you're saying?
No, it's never been case sensitive.
Okay.
Never has been, never will be.
Are characters case sensitive?
Huh?
Are characters case sensitive?
Yes. So if you store a variable, that is case sensitive.
But the actual code itself is not.
Yes, the actual code is not case sensitive, and we can look at that.
So no camel case.
Yes.
Rather use like underscores and stuff like that.
Yeah, use underscores. I'm just going to print all these out so we can see what these look like. G Fortran variables. Cool. Okay, so these are all of our different variables we've declared. So an integer, again, no decimal points, nothing, it's just an integer. Whereas if we've declared a floating point number, it'll put in those decimal places afterwards. A is just the character we declared. T, Fortran will put out T for true. And then for a complex number, it'll give you a pair saying the real and the imaginary part. So like Jeremy was asking, if we come in here and we say, I want my char to be a capital A instead, then yes, it does care for the character, for the actual variable, the value that you're storing, it does care whether it's upper or lowercase. But if I were to come in here and I were to change all of these to be my char, but then I have this one be my char, in Python that would throw an error, but Fortran doesn't care. It doesn't care about my char. I hate that.
It's kinda
Anyway.
nice.
It is nice, yeah. It'll come and it'll bite you in the butt sometimes. Like my index variables are always IJK, and sometimes I'll want to have another variable called capital I that's something completely different, and then the compiler will get mad at me and I'm like, right. So
That's fair.
so be careful about that.
What's this dot true dot?
Okay, so that's how you declare a Boolean variable in Fortran. So false is dot false dot. Certain I don't know what you call them, operators, I guess. Yes, certain. So Booleans themselves or logicals themselves are always bracketed by periods. Logical operators are also bracketed by periods.
Like
so
and or and
yep. So dot and dot true. So if I've got my logical is false and true, that's going to evaluate to false, of course. And you can see there we've got false printed out in the terminal. If I call this or instead, then I get,
recompile.
oh, thank you, I need to recompile. I get true. I believe XOR is built in. No, it's not. There's a not. So if I wanted to say my logical is not true, then it'll be false. The other operators that look like this are like less than, greater than. But usually, so if you want to do like 1, and then you do GE for greater than or equal to 0, in that case my logical will come out to be true. If I want to do less than or equal to, you can also do equal to, and that will come out to be false. Those are, I think that's kind of the old way of doing it. These days you can do kind of just the standard double equals for equal to, and then you can do the greater than or equal to as well, and that comes out to be true. So I prefer to use the explicit symbols as opposed to doing dot equal to or dot GE or whatever, just because this is easier for me to read. But know that both exist. There's also dot anyq, which is not equal. No, there's not. I thought that was one. I guess not. Anyway, so know that those exist. But you probably don't need to use them. Just use the standard greater than equal to, less than equal to, that kind of thing. Okay.
Here's a question.
Yeah.
So in your logical, you had 1 dot less than equal to, or greater than equal to 0 dot. What does Fortran assume that 1 dot and 0 dot are? Does it assume anything about those? Because do you understand what I'm asking?
Yeah. So if you put a decimal place after it, it's going to assume it's a floating point number. It's going to assume it's real. If you so reals, complex, and integers. If you're doing operations kind of with mixed types, like say I want to do my int times my real, it will automatically handle the casting for you. So in order to perform that operation, it'll cast my int to a real, so it can multiply the integer by, so it can multiply by a real.
What about with the imaginary?
With the complex one, I think it would cast everything to a complex. Let's see what happens. So let's give this an imaginary component.
Is there a package for square root or something?
I don't know. Let me see. Times my real. Let's see what the compiler says. And a square root has a negative value. So I just need to.
It's supposed to be imaginary. Okay.
Okay, we're back. Real quick, we learned that if you want to do it, you do complex 1, 1. So this complex function will give you a complex number where this is your real part, and this is your imaginary part. So if we were to, let me clear the terminal. If we were to compile that, oh gee, there we go. Okay. So again, it's taken my real and it's cast that to a complex to be able to do this multiplication there. That makes sense? Okay. Spencer, you got a question?
What are the advantages of having a compiler like this rather than just having it interpret it immediately like Python?
So with a compiled language, what it does is it takes all of your code all at once, and it gives it to the compiler, and it says, hey, turn this into machine code. And it'll take it, and sometimes it'll do weird stuff. It'll unwrap, it'll unravel, do loops, it'll do all sorts of things, and it'll optimize it to make it fast. And then you've got all of your code is now all machine code, and it can just be handed over to the CPU and run. With an interpreted language, what you'll do is you'll take your code and you'll hand it to the interpreter, and the interpreter will start going through your code line by line and taking each line and saying, okay, this is what the code is now asking me to do. And so if you get into something like a for loop, every time it's going through that iteration of a for loop, the interpreter is having to refigure out what is this line asking me to do. And so every time you run your code, the interpreter is having to reinterpret all of your code. Whereas with a compiled language, the compiler takes your code once, turns it into machine code, and it runs. So a compiled language tends to be much, much faster, is really what it boils down to. That makes sense?
Yeah.
Okay. Okay, now that we've talked about these basic variable types, let's talk about arrays.
So it's important.
Yes, arrays are very important. One of the wonderful things about Fortran is that Fortran handles arrays very, very nicely built in. It's not like C++ where arrays are a derived type. Arrays are very much a part of the Fortran language. So, say I wanted to declare an integer array. I would do integer, and then I'll add another keyword to say dimension. And in this, say I want a vector that's 5 elements long, I would say dimension 5. And I'll call this my array. We'll go ahead and get rid of all these other ones for right now. And let's say my array. Now I can set all of the values of my array at once just by saying my array is equal to 1. So Fortran will handle doing entire array assignments. And so you can see we've now got a 5-element array where all the elements are 1.
So, okay. Go for it.
Could
Go
you
ahead.
put a comma in there and then set the number of rows that you would put in there as well?
Yeah, so if I want, instead of a vector, I want a 2-dimensional array, I could just do 5 comma 5, my array, set that equal to 1, and now I've got 25 elements that are 1. The right statement doesn't really have good.
Doesn't make it look good.
No, it doesn't make an array look good. If you really want to make an array to look good, you write a do loop and you print out each row at a time. But this is a 2-dimensional array. So if you want to, and we can look at the size command. Array, and that'll tell us what the size of this array is. And that says this has 25 elements.
Is that rows by columns, the dimension, hypothetically?
Oh, it all depends on. Now here's where we're getting into the really fun nuances of the language. It kind of depends on how you look at it. Rows and columns really only works for 2-dimensional arrays and doesn't tell you a whole lot.
Okay.
In Fortran, so computer memory is not an array. Okay?
Right.
Computer memory is just a long list of addresses. So there's address 0, address 1, address 2, address 3, all the way up to, 2 million, however much RAM you have, basically. Those are the memory addresses. And so any language that's dealing with arrays has to figure out how it's going to take a 2-dimensional or 3-dimensional or 4-dimensional array and break it up and store it in that 1-dimensional memory.
Mm-hmm.
What Fortran does, in Fortran, how do you describe this? The first dimension of the array is the one. I don't know how to explain this. I know how to draw it out, but I don't know how to explain it. You know what? I'm going to draw it out. Pull up a whiteboard here. Okay, so we've got our whiteboard. So if I come in and let's say I've got a, just like we had, let's do a 5 by 5 array. And for the sake of argument, we're going to say, or just for the sake of illustration, that this is our first dimension here, is going down. So the first dimension is the rows, and this will be our second dimension. Okay? So this is as if we've, done that declaration statement where we've said 5, 5. Okay?
Mm-hmm.
So now, again, there's some 1-dimensional memory that this needs to be broken up and stored in. In Fortran, if you're just going through, I'm explaining this the wrong way. In Fortran, what this will do is it will keep the first dimension together. So it's going to take this chunk of the array and store it in one contiguous group. Then it's going to take this chunk of this column of the array and put it down there. And then it's going to take this one and it's going to put it down there.
Mm-hmm.
And so what that looks like is if we're traversing through memory as memory is structured, then the first array element we're going to come across is 1, 1.
Mm-hmm.
Now, as opposed to Python, Fortran has 1-based indexing. By default, you can actually do whatever based indexing you want. That's one of the really cool things about Fortran. It's not particularly useful, but when you need it, it's really useful. Anyway, but default is 1-based indexing. So the first element we come across is 1, 1. The second element we'll look at then is 2, 1. The next element we'll look at is 3, 1, so on and so forth. And then we'll get to this next chunk of memory, and we'll end up with 1, 2. And then we can now go to 2, 2, so on and so forth. Does that make sense? Okay. So this is a good thing to keep in mind because there's something in computer memory called your cache. Say I've got some variables stored in my RAM, and I tell the computer, hey, I want to know what the value of this variable is. It's going to go to RAM, find that variable, and it's going to take not only that variable, but also the chunk of RAM that is next to that variable, and it's going to pull that into cache. And then it's going to use those values stored in cache as long as it can. And so this saves time. You don't have to go all the way to RAM each time. You can just go to cache. So if you're dealing with really, really big arrays, and you say, okay, I want array element 1, 1, it's going to go to, and say our cache buffer is, 32, it can store 32 numbers. So it's going to go to RAM and say, hey, I want the first 32 elements of this array. It's going to take the first 32 elements of the array from RAM, load it into cache, and then it's going to give you that value for 1, 1. Now, if you come back and say, hey, I want array element 2, 1, then it's going to go to cache and say, hey, do you have array element 2, 1? And cache is going to be like, yeah, I've got that, and it's going to give it to you, rather than going all the way to RAM, where it's actually stored. If you get to some point where you say, hey, cache, do you have array element 2913? It's going to say, no, I don't have that one. Go to RAM. And so it's going to go to RAM, and RAM is going to copy back to cache a whole new chunk of that array. So what you want to do is you want to write your code, and so if you're asking for a variable that's not in cache and it has to go to RAM to get it, that's called a cache miss. You want to write your code to avoid cache misses. Now, this is something really nitty-gritty about Fortran, and you might not ever run into this, but it's good to know about. Because of that, if you're doing some operation on an array, it's best to do it in this order, where you go down the columns first. Because as soon as you do an operation on this element, probably most of the rest of this column is going to get loaded into cache. And so working down the rest of the column, you're going to save time by avoiding all those cache misses. Whereas if you went, in this order, going across the rows, you have the potential to generate a cache miss pretty much every single time. So, if you're dealing with really, really, really large arrays, it's best to do it column-based first. Okay, cool. Just a fun fact there. Again, I don't know if you'll ever come across that, but it's good to know about. Okay, so that's a basic array. You can create arrays of any variable type. So I can have an array of reals. I can have an array of characters. I've never dealt with a two-dimensional array of characters. But you can have a 5-dimensional array of characters, and you can say my array is equal to, and this will now be 5 characters long, A, B, C, D, E. Well, that's interesting. I've never seen that before. I don't know why it's doing that. I feel bad recording this and like getting myself into these little spots where I don't actually know what I'm doing. Anyway, I don't deal with character arrays a whole lot. If I am dealing with character arrays, what they will normally be is I will give them, you know what? We're not even going to talk about it. This is more complicated than what I want to get into right now. We will save that for a later date. Okay, so the thing with arrays is at compile time, you might not know how big you want your array. So say I want to run my program once, and depending on an input file I'm reading in, I may want an array that's 100 elements long. But then another time I may want an array that's 300 elements long. And so I can't tell it at compile time what size of array I want to have. And so instead of explicitly telling it how big of an array I have, I'm going to give it dimension, and I'm just going to put in a colon, which is, all this is doing is telling the compiler I want a one-dimensional array. Okay? Say I want a two-dimensional array, I just put in a comma and another colon. And then I will put in the keyword allocatable, which tells the compiler, hey, I want a two-dimensional array, and I'm going to allocate the space for it later. But know that I want it now. And then what you do is you come in later, and you'll say allocate my array, and then you're going to tell the code what size do you want this. So say I want an 8x8 array. There we go. So now at compile time, the code doesn't have any idea what size my array is going to be. Okay? But then once I allocate it, then it knows what size it is and it can do everything I want with it. In allocate, you can put in a source argument to tell it, I want you to set all these elements to 12. Or you can put in another array and say, I want you to copy the values from this array into this new array. If you do have another array and you want it to be the same, these two arrays to be the same size, you don't even have to put in this size specification. So let's see, if I say my other array, and I allocate my array. So if I want my other array to be an exact copy of my array, then I just put as the source my array. And so I don't have to tell it what size it is, I don't have to tell it what the values are, it just knows, hey, the source is my array, make a copy of it. Oh, and I can, I guess I should print out my other array. See? So now we have two arrays that are exact copies of each other. If I try and do it where I have a one-dimensional array that I'm trying to copy to, the compiler's going to get mad at me. See? So the source expression must be a scalar or have the same rank as the allocate object. So rank is the number of dimensions in the array. If I have a one-dimensional array, it is rank 1. Okay, so that's basic variable types and arrays. Yeah, I think we'll call it good for now. Any questions?
Now, if you were trying to manipulate my array so that it's a function of my other array or vice versa, can you write that within it? So like if you were trying to do each element in my array is incremented by I or whatever, if you're doing a loop, then you can do something like that, right?
Yeah, yeah, and I guess I'll show you real quick. Let's get rid of this. So say I can do whole, we'll get into do loops in the next video.
Okay.
But we can do whole array operations. So I could say my other array is equal to my array squared. Unlike MATLAB, because we don't like MATLAB, Fortran defaults to element-wise operations. So this is saying take each element of my array, square it, and store it in each element of my other array. All right, oops. And so now you can see each element of my other array is 144. Now you can manipulate it element by element, of course using a do loop. But if you just want to, if you're doing the same operation to the entire array, just use array statements. Yeah. There are built-in functions for matrix manipulation. So if you have two arrays, you could say like, my other array is equal to mat mul. That's matrix multiplication, and you can put into two two-dimensional arrays, and that will do the matrix operation, whereby you get some other really large number. That makes sense? Okay, sweet. Which I think that's 12 cubed. Anyway, we'll be done for now.